Hi everyone, welcome back to the channel. Today I'll be solving the IGCSE Mathematics paper, subject code 0580. It's Summer 20 question paper 42. We'll be solving question number 4, and it's a question related to triangles. So with every question related to triangles, there is actually an approach we can use. 4 different types of approaches to be more precise. The first one would be using our trigonometric functions. Sine theta is equal to O by h, cos theta is equal to A by h, and tan theta is equal to O by A. And you can remember this using SO, CA, TO. Then our second approach would be the Pythagoras theorem, which is c square is equal to a square plus b square. Our third can be a upon sine A is equal to b upon sine B, which is our sine formula. And our fourth approach is our cosine formula, which is a square is equal to b square plus c square minus 2bc cos A. You would have to know that number 1 and number 2 can only be applied in right angle triangles. So you need a 90-degree angle present. And by the looks of this question, it doesn't seem like there are any 90-degree angles present, so we'll probably only be using approach 3 and 4 or both. So the first part was to calculate the length QR. Now, one thing to make things easier is if, for example, we were given a triangle with vertices A, B, and C, it's a lot easier to denote the lengths by the lowercase of the vertex. So for example, length BC can be easily denoted as lowercase a, length AC can be denoted as lowercase b, and length AB can be denoted with lowercase c. In this case, length QR can be denoted as lowercase p, length PR can be denoted as lowercase q, and length PQ can be denoted as lowercase r. Okay. I'll just put this inside because it'll be easier. Now we have to calculate the length P, and we're given length Q and length R, and we're given angle P. So it should immediately come to you that we should be using approach number 4, which is the cosine formula. So in this case, it would actually be P square is equal to Q square plus R square minus 2QR cos P. So that means 150 square plus 120 square minus 2 into 150 into 120 cos 25. So P would therefore be root of all of this. Now that is 150 square plus 20 square. Root of 4272.92, and therefore P will be 65.4. So part B is regarding length RS, and I've simply copy pasted the figure down here for simplicity. And same way we can denote each side as I've explained above. So this would be P, this would be R, and this would be S. And one other thing we can do is that you should know that every triangle can have a total angle of 180 degrees. So you can actually calculate what this angle will be. So that's 180 minus 55 plus 45, and that is 80 degrees. So I'll just write 80 degrees over here and erase the rest so that it doesn't get in the way. Anyway, we're given 3 angles and 1 length. So what we can do is apply approach number 3, which was the sine formula, where if we substitute our given values, it would be P upon sine P is equal to S upon sine S. Now over here we need to calculate what P is. We know the angle of P is 55. We know that S is 150, and we know the angle of S is 80. So when we rearrange the formula, you get 150 into sine 55 upon sine 80. So when we solve for this, it would be 124.8 meters. Now for part C, we're asked to calculate the total area of the two triangles, and the way we would approach this question is that we'd find the area for each triangle and add them together to find the sum. So for the area of a triangle, there are two formulas you learn in IGCSE, where one of them is half into base into height, or you can have half AB sine theta, where the first formula can be applied in any triangle. You're given the base and the height, and you can apply the formula half into base into height. And the second formula can be applied when you're given two lengths, A and B, and you're given the angle between them. So it would be half into A into B into sine theta, where theta is the angle between them. So just a bit of clarity over there. Because of that, you'll realize that we cannot actually use the formula half into base into height in this question, because we do not have the heights given, nor can we find what the height is. You cannot assume that if we drew a line over here, this would be 90 degrees, then this would have like a, I don't know, 45-degree angle, and then calculate what the height is using the trigonometric functions. That is incorrect, because in fact you cannot exactly make this a 90-degree angle. So instead we'll be using the half AB sine theta formula, and you just have to identify or be able to identify which angle you'll be using and which side lengths you will be using. So for our bigger triangle PSR, we're given this length here, and the angle between them. So 150 can be A, 124.8 can be B, and theta can be the 45 degrees between them. So when we apply that for the triangle PSR, it will be half into 150 into 124.8 into sine 45. The 124.8 was the answer from the previous part of the question. So in the calculator, that is 6618.52. And for triangle PQR, the same thing would be half into, over here we're given this length and this length. This can be A, this can be B, and we know this angle that is in between A and B, which is theta, and that would therefore be half into 150 into 120 into sine 25. And on the calculator, that is approximately that much. So the total area would be the sum of both of them, and that is about 10423.8. And because this is our paper 4, you'd be expected to round your final answers to at least 3 significant figures. Rounding this answer to 3 significant figures would give you 10400. And that is it for this question. If you have any other doubts or questions you'd like us to solve, feel free to leave them in the comment section below. We can solve papers for IGCSE and A levels for all sciences and maths. I hope this video helped, and if it did, consider liking and subscribing, and I'll see you in the next video. Thank you.